Hello, good morning students. Today one of the important chapter in the second year physics, that is current electricity. From this chapter some 10 important problems for the board exams. Look at this. First problem will be the 4 resistors 20 ohms, 40 ohms, 20 plus x ohms, 80 ohms from a Wheatstone bridge. Form a Wheatstone bridge. Find the value of x. This is the question given. As we know that in the Wheatstone bridge, the formula for the Wheatstone bridge is, you know that P by Q is equal to R by S. From the given data, let us say this is P, this is Q, this is R, this is S. Simply substituting it, what you will get? 20 by 40 is equal to 20 plus x by 80. Cancel it. 2 2 ja 0 0 cancel, 2 2 ja 4. So do the cross multiplication, what you will get? So 80 is equal to 2 into 20, 40 plus 2x. That means 2x is equal to 80 minus 40, that is 40. So you will get x is equal to 2 2 ja, that is 20 ohms. The answer for this will be simply x value is 20 ohm. This is the first problem. So second problem. A wire of resistance 4R, this is the wire whose resistance is 4R, is bent into the form of the circle like this. What is the effective resistance between the ends of the diameter? Let us say this is the diameter. Let us say point A, this is point B. Now we would like to find the distance between effective resistance between these two. That means if it is 4R, that means upper part is 2R, lower part is 2R. So you can write it like this. Yeah. 2R, 2R. So this is the diameter AB. Now these two are in parallel. As we know that if they are connected in parallel, what is the effective value? So these are two same. That means we can say that is effective value R effective is equal to, if it is parallel, equal resistance, formula is R by N. That is simply 2R by 2. N means 2. Simply R. So R effective is equal to the resistance between the diameter of the circle is nothing but the R ohms. So this is the formula. So many times ask this problem. Next, question number 3. 3 resistors, each of resistance 10 ohm, are connected in parallel. Calculate the effective resistance of the combination. This will be already you did the same type of problems in the 10th class also. Say let us say 3 resistors, each 10 ohms, are connected in parallel. That means parallel connection means like this. Parallel. So each having 10 ohms, 10 ohms, 10 ohms. These all are connected in parallel. So effective resistance, if they are having the same resistance, means effective resistance, as you know that simply you can write R by N. Parallel means simply R means how much? 10. N means how many resistors are there? 1 2 3 resistors by 3, that is 10 by 3 ohms, or simply you can say that 3.333 ohms. This is the answer for this. Next will be the fourth question. 3 resistors 2 ohm, 4 ohm, 5 ohm are combined in parallel. What is the total resistance of the combination? Here you can write the detail. 3 resistors solution. This is for the solution. 2 ohm, 4 ohm connected in parallel. That means parallel. Same above. Looking like the above diagram. Yeah. These 3 are parallel. One is 2 ohm, another is 4 ohm, another is 5 ohm. If they are connected in parallel, as you know the formula for the RP parallel, which is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So substituting, what you will get? 1 by RP is equal to 1 by 2 plus 1 by 4 plus 1 by 5. Take the LCM. 20, 2 10 ja plus 4 5 ja plus 5 4 ja. Simply how much it will be? 15 19 by 20. That is 1 by R value. Simply R effective will be 20 by 9 ohms. That's all. Next question will be the fifth one. Fifth one. What is the color code for a resistor of resistance 350 kilo ohms with 5% tolerance? First of all, you have to know what is the color coding. Color coding is the important point for the derivation. You need to require the coding formula. So first, B.B. Roy, Great Britain, very good wife, wearing gold silver necklace. So B.B. Roy from black and white. First will be the black, last will be the white. In between black and white, all the colors will present. That is brown, red, orange, yellow, green, blue, violet, gray and white. So for this black, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Gold, for this tolerance is 5%, silver is 10%, no color is 20%. This is tolerance. So first of all, you have to know the formula for this. For this formula is first color side by second color into 10 power third color plus or minus tolerance. That is the formula. So from this given, now from this given data, 350 kilo ohms is given. That is R is equal to 350 into 10 power 3. Kilo means 10 power 3. See? Plus or minus 5% is given. Tolerance. So simply look at this one. First color, second color into 10 power third color. So first color will be 3. 3 means what is the color? Orange. So first color is orange. And 5. 5 means side by second color. Second color means green. Into 10 power third color. So first color, second color into 10 power third color. That means you have to, again you can do this modifications. That is 3, 5 into 10 power, this is 10 power 3, that is 10 power 4 plus or minus 5%. So first color, second color into 10 power third color. Third color is 4. 4 means yellow. So the answer for this will be orange, green, yellow. 5% tolerance is given. 5% tolerance means gold. So for this answer will be color coding of the resistor is orange, green, yellow and gold. That is the answer for this. Next question. You are given 8 ohm resistance. What resistance should be joined in parallel with it to get the effective resistance of 6 ohms? First of all, from this given, 8 ohm resistance is given. So one resistance is given, that is 8 ohms. What resistance should be joined in parallel? That means another resistance which is connected to the parallel here. Say this is some X with it to get the effective resistance. So effective resistance of this will be, effective value will be 6 ohms. That means we have to find the X value, how much. So if these are connected in parallel, that means as you know the formula 1 by parallel, 1 by Rp is equal to 1 by R1 plus 1 by R2. Or simply you can write Rp is equal to R1 R2 by R1 plus R2. So substituting the values, as you know that Rp effective value is given as 6, which is equal to R1 value is 8. R2 we don't know, X by 8 plus X. Now substituting, do the cross multiplication. 8x is equal to 6 8 ja 48 plus 6x, that is 2x is equal to 48. Therefore x is equal to 24 ohms. So answer for this 24 ohms. So if the 24 ohms is connected parallel to the 8 ohm resistance, you will get the effective value 6 ohms. That's all. Next question will be 7th one. How does the resistance of a conductor vary if the conductor is stretched to 4 times of its? So this is the question. For this question, say stretched by 4 times. If it is stretched by 4 times means volume and the density is constant. As we know, the formula for the resistance R is equal to rho L by A. In this case, volume constant means it will be converted into volumes, that is R is equal to rho L by area into length. No problem. That means R is equal to rho L square by volume. Area into length is volume. So density and volume are constant here. You can write R is proportional to L square. That means given condition here is 4 times its length. Or length will be stretched to 4 times. So L2 is equal to 4L1. So what is the value of R2? So you can write it as the double action. That is R2 by R1 is equal to L2 square by L1 square. Now R2 by, let us say, R is equal to L2 means 4L1. That is 4L1 by L1 whole square. L1 cancel, 4 4 is 16. That is R2 is equal to 16R. So resistance will be increases by 16 times. So simply you can write here resistance increases by 16 times. So that is answer. Next question. Now the question is 8th question. A cylindrical metallic wire is stretched to increase its length by 5%. Calculate the percentage in the resistance. Same previous problem, look like previous problem. So as we know, the formula for this will be stretched to increase length by 5%. 5% increase in the length. That means you can get the relation with resistance and length is, as we know from the previous problem, R is proportional to L square. So it will have to write in terms of the percentages. So in terms of percentage means that is delta R by R into 100 is equal to L square means 2 becomes front. That is 2 into delta L by L into 100. This is the formula. So as you know that given condition, given value here is given increase stretched by length by 5%. That is delta L by L into 100 is nothing but 5. Simply substituting it, what you will get? 2 into 5. That is equal to 10. Therefore, delta R by R into 100 is equal to 10%. So resistance will be increased to 10%. That is the problem. Next question. The balancing point in the meter bridge experiment is obtained at 30 centimeter from the left. If the right gap consisting of 3.15 ohms, so what is the resistance of the left gap? So as we know that the resistance meter bridge, which is the works on the principle of Wheatstone bridge, so it will be looking like this. So this is the left gap, this is the right gap, this is the wire. So the question given here is balancing point in the meter bridge experiment is obtained at 30 centimeters. So this is say P, this is a Q. So if it is the balancing point is say R, that is L1. So total length is 100 centimeters. Remaining will be 100 minus L1. So according to the meter bridge formula, the formula will be P by Q is equal to L1 by 100 minus L1. That means resistance is proportional to length. That's why in place of R by S I wrote L1 by 100 minus L1. So from this given data, what the data is given? So L1 is equal to 30 centimeter, which is given, and right gap consisting, that is Q value is 3.5. you have to find the left gap, that is P you have to find. So simply substituting it, what you will get, P is equal to Q into L1 by 100 minus L1, or simply Q means 3.5 into L1 means 30, 100 minus L1 means 100 minus 30, that is 70. So 0 0 cancel, 7 5 is 35.5, 3.5 is 1.5 ohms. So the value of the left gap resistance, that is P is equal to how much you will get, 1.5 ohms. This is about the problem solution. Next, last problem in this current electricity chapter. So this problem also comes in the board exam so many times. So in this, read the question carefully. A battery of EMF 10 volts, a battery of EMF 10 volts, that is EMF is equal to 10 volts, and internal resistance represented by small r, that is 3 ohms, connected to the resistor capital R. If the current in the circuit is I is equal to 0.5 amps, what is the resistance of the resistor? R value you have to find. And what is the internal what is the terminal voltage? That is terminal voltage is V when the circuit is closed. There is a question given here. So for this, simply data I wrote here. What are the data given? First of all, you have to know the current in the circuit. The formula for the simple is current in circuit. So current is nothing but I is equal to voltage by total resistance. So simply voltage here is EMF. That is EMF by total resistance means they are connected in series. That means capital R plus small r. So substituting, what you will get? What you will get? R value will get. Simply I means how much? 0.5 is equal to 10 by capital R we don't know, we have to find, plus 3. So simply do the cross multiplication, or simply 0.5 means 1 by 2. So 1 by 2 is equal to 10 by R plus 3. Do the cross multiplication, R plus 3 is equal to 20. So R is equal to, you will get 17 ohms. That is the answer. Resistance I will find. First question. Second question is, what is the terminal voltage of the battery when the circuit is closed? When the circuit is closed means, when the circuit is closed, as we know the formula, battery potential V is equal to E minus IR. Sorry, small e minus IR. This is the formula. Simply substituting, what you will get? V is equal to E already we know 10 minus I already we know 0.5. R value we know, that is small r value, that is 3. So you will get 10 minus 5 3 ja 15, that is 1.5. How much it will be? 8.5 volts. So you get the value of terminal voltage is 8.5 volts. That's all. This is the derivation. Okay, thank you for watching. All the best for the exams.